Hello friends, welcome to the next edition of Polymeric Process Engineering. Here we are going to discuss about the different polymeric materials used in electronics application. You see that there are wide spectrum of uses of polymeric materials, and in this category the electronics arena is a very prominent user of these polymeric materials, like from packaging to the PCBs to the housing to the casing. In all spectrum you will find those use of the polymeric materials, like the monitor you are seeing this particular lecture, or the mobile phones. On all day-to-day spectrum you will find the polymeric materials are closely associated with the electronics. So, in this particular segment we are going to cover, and there is no need to discuss that where these polymers are associated. So, that is why we are straight away going to the different type of polymers those are being used for the electronics application in different field of life. So, in this particular segment we are going to cover about the polyurethanes. Here we will have the introductory part, then method, and because of the synthesis involves the catalysis operation of the process. So, how we can select the catalyst. So, we will discuss about the catalyst selection mechanism. Then we will discuss about the classification scheme of polyurethanes. Apart from this, there are various tests associated. So, we will discuss all these tests under the umbrella of ASTM. Now, the polyurethane can be used in electronics for a variety of purposes. This may include the insulation, adhesion, encapsulation, and one of the primary advantage of polyurethane is their ability to provide the excellent electrical insulation. They are being used for the insulation purpose. Previously, the glass wool being used for the insulation purpose, but nowadays polyurethane, they are the best, you can say they acquire the best place in the insulation material. Now, the polyurethane coating and adhesives, they are commonly used in electronics manufacturing, especially to protect the components from the moisture, chemical and mechanical stress. And these adhesives are also used in the electronic industry for bonding the various components. Now, these adhesives offers excellent adhesion to the variety of substance that can be used for to bond the metal, plastic and ceramics, because sometimes you need to join the metal plastic in the electronic application. Now, these polyurethane adhesive offer a best candidacy in this aspect. Polyurethane foam, this can also be used in electronics for insulation, vibration damping, because sometimes like fan and other things they impart the vibration and they create the damping. So, this vibration damping can be used as by the help of polyurethane foams. Now, polyurethane foam can be used to protect the delicate electronic component from shock and vibration. So, overall polyurethanes, they are versatile materials that can be tailored to specific electronic application and provide a range of benefits, like from insulation to adhesion to the mechanical protection. All these spectrum, even from the it may create a barrier between the atmosphere and the material in question. Now, another thing is that the polyurethane can be used in the electronics application, like in conformal coating of PCBs. They are the thin layers of material that are applied to the surface of the printed circuit board to protect it from the environmental factor like moisture, dust and chemicals. Now, the polyurethanes, they are preferred in this application because of the excellent moisture resistance. So, they create the barrier between the moisture and the component in question. Now, these polyurethane can be used as a sealant, and these sealant are used to seal the gap and joint in the electronic enclosure. This helps to prevent the moisture and dust. Now, encapsulation, the polyurethane resin, they are commonly used material for encapsulating the electronics component to protect them from the external factor like moisture, heat, chemicals, because they are a very good insulating material. So, the mechanism of polyurethane resin for encapsulation, this involves a chemical reaction, like here you see, between the two resin component, and the main component usually is referred as a polyol and isocyanate, which forms the cross-linked polymer network, and it provides the strong bonding. Now, this polyol is a long chain molecule with a reactive hydroxyl group at its end. Like here you see that reactive hydroxyl group. This isocyanate is a molecule with the reactive isocyanate group at its end. Now when two components they are mixed, a chemical reaction occurs in which isocyanate group reacts with the hydroxyl group to form the NCCO bonding, that is called the urethane linkage. Now the reaction between the polyol and isocyanate component is exothermic in nature, which means that it releases certain quantity of energy and typically initiated by adding a catalyst which speed up the reaction. The resulting material is a cross-linked polymer network, and that is insoluble and chemically stable. Now these resins or polyurethane resins for encapsulation is typically applied as a liquid which then cures and harden over the period of time and it becomes solid. Now this curing process involves the polymerization of the polyurethane resin to form a solid, and they form the protective layer alongside of the component. Now the final properties of the polyurethane resin like hardness, flexibility, chemical resistance, this can be controlled by adjusting the ratio of polyol to isocyanate and the type of catalyst to use. Now here you can see different type of polyurethanes like thermoplastic, flexible polyurethane, rigid polyurethane, then polyurethane isocyanate, then water-borne polyurethane. Like the example, thermoplastic keyboard protector for the laptop, outer case of the mobile. You can see that all these finds a wide application in our day-to-day life. In the flexible polyurethane, the cushion material, carpet, furniture bedding, all those things you can find. And rigid polyurethane, thermal and sound insulator. So you see all these products, they find a wide application in our day-to-day affairs. Now there are various techniques associated with the encapsulation. Now there are several type of polyurethane encapsulation. Now each of this its own advantage and disadvantage. The most common type of polyurethane encapsulation are potting. These techniques involve the filling a cavity around the electronic component with a polyurethane resin. Now this potting provides excellent protection against environment factor like moisture, heat, dirt, dust, chemicals, whatever. It can be challenged to repair or replace component that have been potted. Another is the encapsulation molding. Now this technique involves the placing the electronic component into a mold and then injecting the polyurethane resin into the mold, so that this provides outer layer in that particular thing, and this provides the excellent protection, and it can be used as to produce the complex shapes, but it is costly and time consuming. Conformal coating. This technique involves the applying a thin layer of polyurethane resin to the surface of electronic component, and conformal coating provides excellent protection against moisture and other environmental factor. This can be easily repaired and removed, and they do not provide as much protection as potting or encapsulation molding. Another thing is the transfer molding. Now this technique involves the placing of electronic component and then pouring the pre-catalyzed polyurethane resin into the mold and transfer the molding. Molding provides good protection and are relatively fast and cost effective. It is not suitable for producing the complex shape because the mold and other things, they are very sensitive. So the overall choice of the polyurethane encapsulation technique, it depends on the specific requirement of the application, like the level of protection you require, the complexity of the component, the shape of the component, and how much production volume is needed. Let us talk about the isocyanates in polyurethane synthesis. So isocyanates, they are an important component in polyurethane coating. Formulation, when we talk about the formulation, they are very much important, and when they react with the polyols to form a polyurethane film. Some of the typical isocyanate used in the polyurethane coating are toluene diisocyanate, TDI. This is referred as a TDI. This is widely used isocyanate in polyurethane coating, and it is available in two forms, 2,4-TDI and 2,6-TDI, and is used in both solvent based and water based formulations. Then hexamethylene diisocyanate, HDI. This is another commonly used isocyanate in polyurethane coating. It is the cyclophytic isocyanate, and it is available in two forms: HDI isocyanate and HDI biurate. Isophorane diisocyanate, IPDI, this is another form, and this is a low viscosity aliphatic isocyanate that is used in high performance coating, and it is highly resistant to yellowing and weathering. Sometimes weathering effect is also play a very vital role. In that category, this particular isocyanate is useful. Then MDI, this is highly reactive isocyanate, and that is used in polyurethane coating, and it is available especially in two component system. Then Desmodul N75, this is an aromatic polyisocyanate that is used in high solid coating, and it is highly resistant to chemical and abrasion. Another property of this polyurethane is that abrasion resistance. Then Desmodul L75, this is another aromatic polyisocyanate that is used in polyurethane coating, and it is highly reactive and has a good weathering resistance. Another category is 4,4-methylene bisphenyl isocyanate, MDI. This is very common and very popular one. This is another highly reactive isocyanate that is used in polyurethane coating, and it is often used in combination with other isocyanates to achieve the specific coating properties. Sometimes you require some specific coating properties, and this can be a case sensitive, and this can be used in that particular aspect. Now, when we are having a large chunk of the isocyanate availability, then question arises, how do we select this isocyanate? So, let us talk about isocyanate selection. So, when selecting an isocyanate for a polyurethane synthesis, several criteria should be considered to ensure the desired properties and performance to the final polyurethane product. Now, there are some important selection criteria for isocyanate in polyurethane synthesis, and we are also giving you some example for the same. First one, it is very common, that is a reactivity. The isocyanate should have an appropriate reactivity to achieve the desired curing or cross-linking rate, and the reactivity affects the processing time, pot life, and the final properties of the polyurethane. The example of such isocyanates with the different reactivity level includes the toluene diisocyanate, TDI. This is highly reactive isocyanate and commonly used in the flexible foam application. Then methylene diphenyl diisocyanate, MDI. This is moderately reactive isocyanate and suitable for wide range of polyurethane application, this including the rigid foam coating and adhesive. Another selection criteria is the compatibility. Now, isocyanate should be compatible with the other component in the polyurethane formulation like polyols, additives. Compatibility ensures good mixing and uniform distribution of the component, leading to the improved mechanical properties and stability. Now, aliphatic isocyanates, they are hexamethylene diisocyanate, referred as HDI, or isophorane diisocyanate, IPDI. They are commonly used in coating and adhesive due to their excellent compatibility with various polyols and good UV resistance. Another criteria for isocyanate selection is performance requirement. The choice of isocyanate should align with the desired performance characteristics of the final polyurethane product like mechanical strength, chemical resistance, thermal stability, and flexibility. Like polymeric isocyanate, these polymeric isocyanates such as MDI, PMDI, they offer improved mechanical properties and enhanced durability, and they are often utilized in application requiring high strength, impact resistance like automotive parts and structural adhesives. They are the best candidate to use these polymeric isocyanate. Another selection criteria is health and safety consideration. Now, this is prime importance nowadays, and because of the various regulations, various regulatory bodies, they are putting forward so many regulations, and they are more concerned towards the health and safety operations. So, that's why the isocyanate selection again based on the health and safety consideration. So they are known to have a sensitizing properties, and they can cause the health hazard because of the presence of isocyanate uh, embedded in it. Now, it is crucial to consider the health and safety aspect of the chosen isocyanate. This include volatility, heating requirement, and exposure limit. And sometimes if the component is there, then VOCs, and if it is there is a fire hazard, then the limiting aspect should be there. The cycloaliphatic isocyanate, they are the best candidate, like isophorine diisocyanates. They are less volatile and they have the lower health and safety risk compared to the other aromatic isocyanates. And they are often preferred in application where reduced toxicity and lower odor, they are important, like in medical devices and the consumer products. Another important factor which involves in the isocyanate selection is the cost. This is play a very vital role in the isocyanate selection. As different isocyanate, they vary in prices. The cost should be balanced with the required performance and application needs. So you must have some certain sort of an optimization and a balancing among all the desired properties and the cost in question. Now these criteria, whatever discussed, those 5 criteria in the previous slides we discussed, these criteria can guide the selection of an appropriate isocyanate for polyurethane synthesis, and they ensure the desired properties, processing characteristics, and safety requirement of the final product. Now, it is recommended to consult the technical data sheets. Usually, material safety data sheets are always available and readily available, apart from the industry guideline, and expert to make the informed decision based on the specific application requirement, because the specific application requirement, that the isocyanate selection may vary. Now, since we discussed about the isocyanate selection and the different isocyanates, then it's a time to have a classification stream of polyurethanes. Now, usually the classification based on the production method. One is that one-shot method. The all reactants, they are mixed at once. Then pre-polymer methods, the isocyanate and polyol, they are first reacted to form a pre-polymer, which is then reacted with the chain extender to form the final product. Now the classification again, based on the chemical structure. Like we may have the aliphatic, we may have the aromatic, and then we may have the cycloaliphatic. Another class of polyurethane based on the classification based on application. The polyurethane can be used for the coating, they can be used for the adhesive, they can be used as an foam, they can be used as an elastomer, and they can be used as a sealant. Another class of the classification is the classification based on hardness. This may be a flexible or a rigid foam. Then the classification based on the functionality, like diisocyanate based or triisocyanate based. So you can, based on these functionality, you can classify them. Then another classification is based on the molecular weight, maybe high, medium or low molecular weight. Now let's talk about the ASTM testing methods for polyurethane. Usually the ASTM, American Society for Testing and Materials, ASTM, they developed several standards for polyurethane materials. They are used in the various applications. And some of the most popular standards used for the polyurethane characterization, they are like ASTM D1621. This standard test method for compressive properties of rigid cellular plastic, and this test method is used to determine the compressive properties of a rigid cellular polyurethane foam. Then another testing method is that ASTM D3575, the standard test method for flexible cellular materials, polyurethane, latex and rubber. This standard covers various test methods for evaluating the physical properties of the flexible cellular polyurethane foam. This may include the density, this may include the compression force deflection, this may include the tear strength and tensile strength. Another test method, that is ASTM D395. This is the standard test method for rubber property or rubbery properties, the compression set. Now, this standard covers the determination of the compression set properties of elastomeric materials, this including the polyurethane. Another test protocol is ASTM D412. This is the standard test method for vulcanized rubber and thermoplastic elastomer tension. This standard covers the measurement of tensile properties of vulcanized rubber and thermoplastic elastomers, and this includes the polyurethane. Then ASTM D2240, this is a standard test method for rubber properties, durometer hardness, and this standard covers the measurement of the hardness of rubber and plastic materials. This includes the polyurethane. Again, one of the most popular test method is ASTM D648. This is the method for deflection temperature of plastic. So, under the flexural load, this standard covers the determination of the deflection temperature of plastic. This includes the polyurethane under flexural load. So, these ASTM standards, they provide a consistent and a reliable way to evaluate the properties and performance of polyurethane material used in various applications. So, depending upon the properties of these material, the ASTM also classify them. Like one is the one component blocked polyurethane, that is ASTM type 3. The one component system with the blocked isocyanate groups see the mostly used in the electrical application and particularly in wire coating. The active isocyanate groups are made latent by interacting with other organic compound that contains active hydrogen atom, or in order to prolong pot life and produce more and more aesthetic pleasing one component system. So, the pre-polymer is non-reactive and has an infinite shelf life, and in this case state known as blocked isocyanate. The blocking ingredient separates when it is heated and released isocyanate group. This may be the polymerized and appropriate hardener components, and the most used blocking agent is phenol, although there are also additional agents including cresol, methylethyl ketoxim, butanol and caprolactam. The temperature requirement or temperature required to unblock the phenol adduct is about 160 degrees Celsius. Now, such high processing temperature usually limit the use of type 3 polyurethane, and they cannot be used for temperature sensitive electronic components and hardware, because the segment may get deformed, and then whatever product you are requiring, in that case you may not have the desired properties. So, however, they are very ideal for wire and a coil insulation and for coating other materials or metal or ceramic. Now, objects prior to the attachment of temperature sensitive part, like other adducts with the lower unblocking temperatures, they are available, like the malonic ester adduct, which unblocks at 130 degrees Celsius. Another class based on ASTM, that is two component pre-polymer polyol ASTM type 5. These are widely used for corrosion protective and high reliability electrical insulating coating. Now, component A is usually a toluene diisocyanate or polyisocyanate pre-polymer. They are also known as adduct, and component B is hydroxyl containing resin. The most commonly used B component are hydroxyl terminated polyesters, polyethers, polyol, castor oil and some sort of epoxy resins. The polyethers, they are based on polypropylene oxide and are termed as polypropylene glycols. A large variety of these glycols differing in molecular weight and viscosities are available. So, both the polyethers and polyesters range from long linear structure as in generalized formula for a hydroxyl terminated polyether or highly branched structure. Now, by proper selection, the properties of the coating may be varied from highly flexible to very hard or brittle. So, as a rule, most linear structure, the more flexible the resulting film, and the more branched structure, the harder and more chemically resistant the coating will be. Another type of classification is based on two-component catalyst cured system and referred as ASTM type 4. So, the type 4 system consists of an isocyanate resin as one component and a catalyst as a second component. The urethane reaction is base catalyzed, hence a small amount, say 0.5 to 4% of basic alkaline material may be used to initiate the polymerization. Among the commonly used catalysts are tertiary amines. The combination of two different catalysts have been found in more active than either catalyst use alone. This enhancement achieved by combining two catalysts, they are called the synergistic action. Example of is that the combination of tin catalyst and tertiary amines. Another type of classification is one component oil modified system, uralkides, that is ASTM type 1. Now, one component polyurethane system, they are commonly available. They are based on urethanes containing as part of their structure modified drying oils such as linseed oil, and they are referred to as uralkides, urethane oil or oil modified urethanes. In their manufacturing, the oil is first partially de-esterified to give a mixed hydroxy ester, and the free hydroxyl group of these esters can then react with an diisocyanate to give the pre-polymer resin. Now, here you see that this represents the fatty acid portion or double bond like this, and it should be noted that this particular resin cannot polymerize further though through the free isocyanate group because none are available. Here you find no one is available. The polymer does, however, contain many double bond ethylenic group in the fatty acid portion of the oil and therefore cures by air oxidation. Now, free radicals, they are formed from the active methylene group adjacent to the double bond, and the several units may then combine to form a high molecular weight polymer. The addition of drying catalysts such as cobalt or manganese naphthalate will then accelerate the air curing and take free time to 2 to 5 minutes at a room temperature. This may be achieved by the addition of such dryers. The main feature of uralkide resin coatings is their lower cost in comparison to the polyurethane types. This is a result of the lower cost of the naturally occurring oil used in their synthesis. Like alkyd, they exhibit very good water and alkali resistance, but they are marginal in color and gloss retention, which is very important. Now, they are not as extensively employed for the electrical application as blocked polymer or the two component system, since they do not have the high overall performance characteristics. A rapid air drying formulation which becomes tack free in 2 to 5 minutes. Another type of a system is one component moisture cured system, ASTM type 2. The moisture cured pre-polymer, they are obtained by the reacting hydroxyl containing material such as castor oil, hydroxyl terminated polyester or hydroxyl terminated polyether, which an excess of toluene diisocyanate pre-polymer adducts having the free isocyanate groups, which is then obtained. You can see in this particular formula. Now, thin film of these pre-polymer, this will then cure on exposure to the air moisture. Atmospheric air contains a sizable amount of a moisture, and then the curing mechanism involves the cross-linking of molecule through the formulation of the urea linkage, and it may be represented like this. Now, moisture cured polyurethane coating, they are among the toughest and the most abrasion resistant coating available. They command the widest use as a floor wood and appliance coating, which is again very important, and their use in the electronics is very limited because the time required for a complete cure depend on the relative humidity, and they may therefore vary considerably from day to day and place to place. And apart from this, it would be difficult to adhere strictly to production specification film. 1 to say 3 mils thick might require 45 minutes to 12 hours to harden, and depending on the formulation and relative humidity. It is also difficult to prepare good coating by baking, And again, because the humidity in the curing oven is very low because of the high temperature, and the coating may remain in an uncured or semi-cured condition. Now, another type of classification is one component non-reactive, that is ASTM type 6. Now, these polymers are pre-reacted and thinned with solvent like alcohol, N-methyl 2-pyrrolidine, toluene, or methyl ketone. Now, these may also be purchased as anionic colloidal urethane elastomer dispersion in water solvent mixture. Now, these systems are primarily used as impregnates for fabrics, leather, and paper, and as a primer and top coats for other plastics. So, type 6 urethanes are not generally used for coating the electronics. So, dear friends, in this particular segment, we discussed about the various aspects of polyurethane. We discussed about how these polyurethanes are classified and how their standard and test methods are being classified. For your convenience, we have enlisted so many references. You can use all these references as per your convenience. Thank you very much.